Hello all, welcome to my YouTube channel PK Chemistry. We are discussing molecular rearrangement. We discussed the two type of rearrangement. One is intramolecular process, another one is intermolecular process, and also discussed the classification of molecular rearrangement. Rearrangement to electron deficient carbon, electron deficient nitrogen, oxygen, electron rich carbon. In that series, we discussed Wagner meerwein rearrangement, pinacolone rearrangement, and semipinacol rearrangement, Dienone Phenol rearrangement, and finally we discussed in the last lecture benzilic acid rearrangement. Now we are going to discuss rearrangement to electron deficient nitrogen. There are 5 rearrangements in rearrangement to electron deficient nitrogen. One is Hofmann, then Curtius rearrangement, Schmidt rearrangement, Lawson rearrangement, and Beckmann rearrangement. We can write a general formula for rearrangement to electron deficient nitrogen. So for O minus double bond N bond X, so minus X minus C double bond O bond, this is isocyanate. So X is if a bromine, so that reaction Hofmann. If the eliminating group nitrogen, then that is Curtius and Schmidt. If the elimination is carboxylate anion, that is Lawson rearrangement. Hofmann rearrangement is conversion of amide to amine. For example, primary amide in the presence of bromine and alkali gives the amine product with loss of one carbon atom. This is amide, this is amine. Mechanism: amide in the presence of bromine forms a bromoamide, double bond NH bond Br. Next step is presence of base, it will form a or C double bond O bond N minus bond Br. Yes. Next step is the resonance structure. So the oxygen stabilizes the anion or bond CO minus double bond N bond Br. The next step is the elimination of bromine as well as migration of or alkyl or aryl group to electron deficient nitrogen. So what you will get is C double bond O bond double bond N bond R. This is isocyanate. Isocyanate. So if you hydrolyze isocyanate, you will get a amine or NH2. In presence of ROH, you will get a urethane or bond NH bond C double bond O bond OR. Optically active amides undergo rearrangement with retention configuration. So the rearrangement is stereospecific. For example, phenyl H amide NH2 in the presence of bromine and alkali followed by hydrolysis. What is the product? So amide converted into amine, right? So this is amine, this is hydrogen, this is S configuration, written in the same configuration S. This 2-phenyl propanamide, this is alpha phenyl ethylamine. If you take 1-methyl cyclohexylamide in the presence of bromine and alkali, what you will get is the amide converted into amine. So you will get a NH2. This is 1-methyl cyclohexylamine. So you are losing one carbon atom. So if you look at this example, what is this? This is 3,4-dimethoxy benzamide. So in the presence of bromine halide and alkali followed by hydrolysis gives the amine product. So what you will get? So loss of carbon atom. So the result in the formation of so you will get a 3,4-dimethoxy aniline. So the next step is amide converted into amine in the presence of bromine and alkali. So you lose the carbon atom. So what you will get? NH2. So this is neopentylamine from 3,3-dimethyl butamide. So if you take this example, succinamide in the presence of base, what will happen? It will attack the ketonyl position. You will get a double bond NH2 bond, double bond O minus. Next step is bromine and alkali, anyone, sodium hydroxide or potassium hydroxide. What you will get? The amide is converted into amine. So the product is NH2 double bond O minus. So if you hydrolyze this one, what you will get is you will get a acid NH2 bond double bond OH. This is beta alanine. So the Hofmann rearrangement useful to synthesis the amino acid. Take similar example to succinamide. This is phthalimide in the presence of base. What you will get is double bond O bond NH2 amide. So you will get a COO-Na. The next step is NaOBr and HCl. So what you will get is amide converted into amine, right? So this is amine. Presence of acid, it will get hydrolysis COOH. This is anthracanic acid. This is nicotinamide. Presence of bromine and alkali, you will get a aminopridine. This is N-alkyl urea. So what we will get in the presence of base and bromine? So you will lose the carbon atom. So you will get a or NH bond NH2. You will get a hydrazine. So amide converted into amine. Amide converted into amine. So in the presence of bromine and alkali, amide converted into amine called Hofmann rearrangement.